Hi everyone. Welcome to my tutorial on traffic sign detection and classification. This is my project one submission for CS663. Today I'll cover why this topic is important, the methods used, datasets, successes and failures, um, and challenges involved, and in the future directions of um, of this research. Traffic sign recognition is an important computer vision task. It helps with road safety for autonomous vehicles and accessibility for people with low vision through assistive apps. In this talk, I'll cover classical methods, deep learning approaches, datasets, successes and failures, challenges, and future directions. Before deep learning, simple approaches were being used. Color-based detection, which detections which isolated red or yellow regions. um, Shape-based detection methods like the Who transform which detects circles, triangles, and octagons. And finally, handcrafted features such as histogram of oriented gradients combined with SVM classifiers were extremely popular. These all of these models they work in control settings, but they fail in real-world cases with occlusion or blur. Uh, Deep learning has absolutely transformed this field altogether. Convolutional neural networks automatically learns features and lightweight networks like YOLO-tiny and MobileNet they allow real-time use on mobile devices. More recently, transformer-based methods have been introduced which improve accuracy for small or occluded signs. Deep learning still dominates research, but efficiency remains a key challenge. Datasets are really essential for training and evaluation. GTSRB is the most widely used for classifications with 43 classes and 50,000 images. BelgiumTSC has uh, has around 62 classes, and it's pretty large scale as well. TT100K is another one with 221 classes and 100,000 plus images. MTSD is newer with more than 300 classes from multiple countries. Um, so it's more about diversity as well. Models are evaluated using accuracy, precision, recall, F1 score, and mean average precision. So talking about the successes in this field on benchmark data sets like GTSRB, models tend to achieve way more accuracy, and in a lot of cases, it's often above 98%. In clear daylight with centered visions, recognition works extremely well. This shows the strength of modern methods in ideal conditions. In real world conditions, performance drops though. Models can miss signs that are small, distant, blurred, or occluded. Poor lighting, graffiti, and weather conditions also reduce accuracy. That's why research is ongoing and being worked on. Um, the challenges they come in two groups. The technical challenges, which include the scale variation, motion blur or low lighting, occlusion, and differences across countries. Deployment challenges include efficiency and speed. Uh, Models mostly run in must I mean they are supposed to run in real time on mobile or embedded devices, so balancing accuracy with efficiency that remains a key problem. Looking forward, the focus is on lightweight and quantized models for efficiency. Transformer-based approaches are becoming more common. Integration with accessibility apps is also promising, such as apps that can read signs aloud and provide haptic feedback um, to the users. Here are the some a few modern references, including papers on lightweight CNNs, YOLO variants, transformer-based methods, and surveys. The full annotated bibliography is available on my um, GitHub Pages tutorial website. So this is the tutorial site that I built. It's pretty simple and I've kept it pretty easy. It starts with an overview of traffic sign detection and classification, explaining why it's really important for both safety and accessibility. Here I show the classical methods, the color filtering, shape detection with WHO, and HOG plus SVM. They are simple but not robust in the real world. I've integrated the audios as well, and so you can so when you come to the website, you can listen to these audios, and they'll give you a better understanding of all the things that you need to understand. Uh, Learning methods learn features automatically. CNNs, YOLO-tiny for real-time detection, and transformers for small or occluded signs. Um, Here is a simplified CNN architecture, which takes an input and uh, which passes through a convolutional layer, and eventually it gives a certain output, right? And Here is how it works, right? So whenever it detects a certain sign, uh, based on the model, this is how it understands it. Talking about the datasets, there are three major datasets that are there. The GTSRB, BelgiumTSC, and TT100K, which are used to train and test models. Mapillary aids global diversity. Um, Evaluation uses accuracy, precision, recall F1 score, and mean average precision. So here is an interactive set where I have taken this data set from GTSRB. So, and this is what um, some of the classifiers and images look in GTSRB. So yeah, should do it for you. Models perform extremely well on benchmarks, but they fail under blur, occlusion, or poor lighting. Um, Here's an example of how it works under good conditions. And here's when the surroundings might be blurred, or the signs might be occluded, or and stuff. So I've included a quiz in there as well, where we can see that the sign is pretty blurry, and hence uh, this is because of the poor visibility that this sign doesn't get detected. Let's talk about the challenges. So challenges, they include both technical and deployment challenges. Uh, t- uh, Technical issues include motion blur and occlusion, and development constraints. Deployment constraints include um, speed and efficiency, which is yet to be figured out. So the future directions. They include lightweight quantized models, the models that can work with mobile devices and doesn't take a lot of toll on them. So transformer, so the future directions will generally include the quantized model, transformers, and accessibility apps that can read signs aloud and provide haptic feedback. So this is pretty much it. That concludes my tutorial. You can take a look at the references and bibliography that I've used. You can go through these pages, and these were wonderful resources for me. and they're pretty modern as well. So yeah, this should help you out. Thank you so much for your time, everyone.